In this video, we'll look at the hooks API, which enables us to empower function components with state, behavior, and even reusable logic. Let's dive right in. When React was originally built, the only kind of component that you could build were class components. You're already familiar with class components. They are subclassed from the component class in the React library and offer built-in support for state and lifecycle methods that allow developers to customize behavior of the component easily. On the way, we got function components. They are just simple JavaScript functions that return a React element and can also take props. They are about the simplest thing that you can understand and use in React, and they are more readable and easier to debug than class components. Having said that, when a function component's scope of work expands to necessitate the use of state and lifecycle like behavior, the traditional approach has been to rewrite the component as a class component. If you've ever done that, you can immediately spot a problem here. As a developer who's spending time and energy on an evolving product, why would I even think about investing time in building function components when they might just have to be rewritten in the future as a class component? This was always a pain point. Just how do you decide what type of component to build? Should you build a feature-rich class component from the get-go or build a much lighter, legible, but feature-deficient function component? And what if you do build a function component and at a later stage it requires the use of state and lifecycle functions? Then what? We cannot argue with the fact that function components feel better overall because they're simple to understand. So the question that comes to mind is, if you're going to invest time in building cleaner and more readable function components, then shouldn't function components be able to work with state and other advanced features that typically class components enjoy? This is one of the reasons why the React team introduced the amazing Hooks API in version 16.8. In the simplest of words, hooks let you implement most of React features in function components. The React team outlines three motivations behind the introduction of the Hooks API. To begin with, class components can become complex and consequently are harder to understand and read than function components. This is important not just from the point of view of developer experience, but also from the perspective of debugging and maintainability of components in large applications. A class component can contain lifecycle methods such as component did mount, component did update, and component will unmount, and others, besides instance methods, state, and other features. As the class component evolves and more of these features are added, complexity increases and readability decreases. Often unrelated code such as this situation here, where we are instantiating a timer instance as well as fetching initial data from an API, get huddled together in the same lifecycle method. This can easily introduce bugs that are equally difficult to spot and squash. And with class components, you cannot break this down further into smaller components or functional units. So you're bound to get stuck at some point or the other as your component maxes out in complexity. The second point is that classes, in addition to being difficult to read and understand, can also be tough to optimize and process by compilers and the toolchain, rendering the process somewhat unreliable. Class components are difficult to optimize and minify when compared to function components. So function components are simple, faster, easier to read and optimize. That is 100% win. The last and most important motivation behind hooks is that it simplifies the process of authoring reusable and stateful logic. Besides components as the fundamental way to write reusable features, React developers typically implement two patterns for authoring reusable logic. The first is render props, which enable you to hive off logic and state while enabling you to implement custom render logic. Render props enabled components simply return a function that needs to return React components. The second technique is higher order components, which are components that accept other components and return a new component that can be augmented with new features. This allows you to write components that can power up existing components with new features and is a commonly used pattern in products such as Redux. Besides these, sharing stateful data and logic across components can also be done using the Context API, which involves the use of the provider and consumer components. But with all these techniques, you can easily end up in a situation that the React team calls wrapper hell. Look at this example. You can see multiple levels of data consumer components here that are nested. Naturally, there is a need to untangle such complicated hierarchies and simplify components while still being able to author reusable and stateful logic. With these motivations in mind, let's see what the hooks API is all about. Hooks let you take a simple function component and incrementally add state, reusable logic, and behavioral features such as side effects and more to function components. These are core React features that were out of bounds for function components till now. Hooks are optional, which means you don't have to use hooks if you don't want to, and it doesn't break any existing conventions or APIs. It is also critically important to note that hooks do not work with class components and are designed only to be used with function components. Hooks as a feature can be gradually brought into an evolving product without the need to rewrite components or parts of your application. This is quite important to understand because one of the core benefits of React as a library is that it can be gradually adopted. This makes it straightforward to build your product, knowing you can incrementally add features without breaking or completely rewriting your code. React offers a bunch of built-in hooks that enable the addition of state, context, side effects, refs, memoization, and other features. Hooks must follow a standard naming convention even if you're authoring your own hooks. A hook function must begin with the word use, as you can see here, and must use camel case for the name. For instance, the useState hook can be used to create stateful properties easily. The useEffect hook lets you run side effects and somewhat resembles lifecycle functions like component did mount, component did update, and component will unmount, all in a single function. The useContext hook can be used to bring in context data without the need to write consumer component hierarchies. The useReducer hook enables the creation and management of complex state logic, which is like Redux, a popular and global state management solution for React. Besides these, there are several other hook functions available that offer a range of opt-in features such as memoization, references, and more. What really shines out above all these features is the ability to write your own hook. Now, having said all of this, the React team has laid down two explicit rules that you must follow. The first rule states that you should never call hooks inside conditions, loops, or nested functions. Instead, always call your hooks at the top level in your function components. This is important to ensure that hooks are evaluated in the order they are defined every single time the component renders. This ensures that your function component behaves correctly. The second rule states that you should never use hooks in regular and arbitrary JavaScript functions. Instead, you should only use hooks in either React function components or even custom hooks, which are regular JavaScript functions but with a specific naming convention. All custom hooks must begin with the word use. These rules ensure that state and logic implemented using hooks is clearly visible and understood by reading the source code. Remember, hooks offer an opt-in way to create and share reusable and stateful logic. This means you can write a feature that components can share and can also contain its own internal state. And here's what you must remember. Hooks are just functions that share data and logic. And what is more interesting, you will absolutely fall in love with them. In this module, we'll look at the useState, useEffect, useContext, and the useReducer hooks before writing our own hook. So let's begin this exciting journey by investigating the useState hook first in the next video.